Okay, now let's follow up with a question that's related to how quickly that rate of change is changing. Okay, so say if the rate at which the rate of change of y with respect to x is changing when x equals 12.3 is negative 11.7, then by how much do we expect our estimate of the new y value to have been off? So you might want to give that a little thought. You might draw a blank, but if you think about it a little bit, there's at least something you should be able to do if you just think about the meaning of the words. Okay, so hopefully you paused and thought about that, but in any case. Okay, well, if x changes by 0.2, which it does, then this rate of change is going to indicate a change of 0.2 times negative 11.7, about negative 2. Now, this is a rate of change. That's a rate of change with respect to x. So, and let me just append something up here. If the rate, and I'm going to say with respect to x because I never put that in there. If the rate with respect to x at which the rate of change of y with respect to x is changing, etc. Now it's more justified in saying this, that this is a rate of change with respect to x. Okay, if you read this statement, deconstruct the statement, you'll see that this is a rate of change of something with respect to x. And let's not even worry yet about what that's a rate of change of. Okay, it's a rate of change of something with respect to x. So, I'm being a little vague. I could be a lot more specific, but I think it would be more likely to get messed up in the specifics if I leave them for a little bit of clarification at the end. So that quantity, the quantity whose rate with respect to x is this. Okay, so that quantity changes by about 0.2 times negative 11.7 equals negative 2.3. It's 2.34, but keeping things to about two significant figures, and I'm not going to discuss the significant figure thing here. I don't want to distract from the main thrust of our reasoning. Okay, so now what is it that changes by negative 2.3? We want to be real clear on that. So the next question is, what is it that changes by negative 2.3? So what exactly is it that changes by negative 2.3? Okay, you might think, well, it's the value of y, but that's not it. The y value changes by something like 4.3, but we're trying to modify that estimate. Okay, so in terms of the statement up here, just what exactly is it that changes by negative 2.3? You should think about that. Well, what it is that changes by negative 2.3, this is the rate of change of the rate of change of y with respect to x. So, leaving letters out, let me fix that. Okay, the answer is it's the rate of change of y with respect to x, not y. Again, because this is the rate at which that rate of change of y with respect to x changes. So when we find the change in that quantity, we found the change in the rate of change of y with respect to x. Now, how does that modify our estimate of the new value of x? Well, our conclusion. So, and I had to insert this up here, when x changes from 12.3 to 12.5, that's probably implicit, but I decided I wanted to write it very explicitly. The average rate of change of y with respect to x changes from what to what? What numbers would I put in here? Well, if you recall, the rate of change of y with respect to x was originally 21.6. So we started at 21.6, and let me just go ahead and bold that by contrasting colors. 21.6 to what? Well, if it changes by negative 2.3, we subtract 2.3 from 21.6, you get 19.3 if I did my arithmetic correctly, and you always want to check that. So we changed from 21.6 to 19.3. Now, what are the implications for the estimate of y when x equals 12.5? And you want to think that through a little bit, but I'm going to go ahead and answer it. Okay. The best estimate of the rate of change of y with respect to x from x equals 12.3 to 12.5 using our new information is what? What do you think our best estimate of the rate of change would be? Well, if the rate of change is 21.6 at the beginning of the interval and 19.3 at the end of the interval, then you would expect that the average rate of change might be the average of these two numbers. It would be somewhere in between here. Now, with further information, we might find that that's not really true, but given the information we have, that's our best guess. So that would be the average rate equals 21.6 plus 19.3 divided by 2, and that's going to be 20.5. It's actually, I believe, 20.45, but rounding up, we'll use 20.5. So what's our new estimate? Okay. Again, you want to think that through before you watch me do it. Change in y, it should now be approximately 20.5, which is our new rate of change, times our x interval, 0.2, which equals now 4.1 rather than 4.3. So the y value at x equals 12.5 is approximately the original y value, which is 4.7, plus the change in the y value, which is 4.1, which is, I was going to try to write 9.8, it's 8.9, so I'm going to fix that. Okay, 8.9. It's 8.8, not 8.9. Okay, so there we have it. Now there's an infinite regress of possible changes to all this, okay, or possible refinements to our estimates. If we know the rate at which the rate of change of y with respect to x changes with respect to x, that is, if we know how quickly the rate that we use to get our estimate of negative 2.3 for the original rate of change, if we know the rate at which that quantity changes, we can modify this estimate in a very similar way. Now, I'm just going to point out that we can do that. I'm not going to actually do that or actually expect you to do that. But, of course, that idea underlies the whole idea of the Taylor series, which is something that hopefully you gain some competence with in your calculus course. There's much more that can be done with Taylor series. Very important idea, but I'm not addressing it at this point. Okay? Very much related, though, to what we're doing here.